Okay, so we've been looking at how to solve trig equations in the last few lessons, and so in the past it's always required you to have a knowledge of the graphs, and that's always, it's always important to know what the graphs look like, but there are going to be some faster ways than just having to sketch them out and intuit the answers. And you will be given these general solution formulas that you can see here on the right hand side. And in this video, I'm just going to run through a few problems that show you how to use those general solutions. Okay, so please don't use these blindly. They should be used to make life easier, but you should still be aware of what the graphs are going to be looking like and where your solutions are sitting. So anyway, if you have a look at the first example, we've got 10x equals 1 and x is going to be between 0 and 360. So the first thing we know is there should be two solutions. But with this one here, what we do is we would solve it like normal. So go x is equal to inverse tan of 1, which is 45 degrees. Now what that does is that gives us like our theta in these general solutions, and we just come down to our general solution, and you can see that the solution is going to be n pi plus alpha, they've called it. So this is our alpha, I guess, if you like. Now we're dealing in degrees, so pi is 180, so it's going to be 180 n plus 45 degrees. Okay, so that's how we're using this equation over on the right here. So the pi has been replaced by 180. Now n is just something we just try. So basically we try different values of n and we get answers for x, and we keep trying different values of n as long as the answers fit in that domain that we're given. So in this case here, if I made n equals 0, then x would be equal to 45, which is a good answer. If we say n equals 1, then x will be 180 plus 45, which is 225, which also fits in our domain. If I go up to n equals 2, then that's going to be 360 plus 45, which is too high. Okay, we've gone too far. And besides, we knew we could have stopped after the first two because there should be two answers here. So our answers are 45 and 225. Okay, so what we're doing at each point is trying to find this alpha term that they've given us here, and then we try values of n. So we have a look at the next one here. I'll just move this down. Okay, so remember, you are given these, you don't have to memorize them. So what we're trying to do at each point is get the cosine or the sine or the tan function all by itself. So here I'm going to divide both sides by 3. And then once I've got to that point, take the inverse trig function. And that will give us, and I will quickly do that on my calculator, 60 degrees. Now that means our alpha is 60. So now we come to this little general formula here. So we know that x is going to be equal to 2n theta. So that's, sorry, 2n pi. Now 2n pi is like 360 n because pi is 180 plus or minus alpha, which was the 60. So in fact, I probably should have put alpha there, but anyway. So just we try different values of n. So if n is 0, x will be plus or minus 60. So it must only be 60 because clearly we can't go outside our domain that we've been told. If we try n equals 1, x will be 360 plus or minus 60. So that is 300 and 420. Now 420 is outside the domain we've been given, so we can ignore it, which leaves us with our two solutions, 60 and 300. Okay, so this video might be a little bit longer just purely because I'm going to go through a variety of the different types of problems you might strike. So just bear with me a bit. With these ones here, you can see there's a couple of things that we have to undo. We're trying to get the trig function isolated by itself. So the first thing I do is take away the 3, then divide by 2. And now I've isolated it, I can now do my inverse tan. Now we're dealing in radians here. So when I'll just quickly change over to radians on my calculator. In fact, I don't know why I'm doing this because we can probably do this in our heads. And that is pi over 4 or 0.785. which is absolutely fine as well. Now we come to our general solution for tan. Here it is over here. So x is going to be n pi plus pi over 4. And we just try the different values of n. So if n is 0, x will be pi over 4, and if n is equal to 1, I'm running out of space, sorry, x will be pi plus pi over 4, which is 5 pi over 4. And I can't go any higher because then I would end up with 9 pi over 4, which would go outside my domain. So my two answers there would be x equals pi over 4 and 5 pi over 4. Where these get a little more interesting is where you have the frequency that's been changed. So in this case here, when we do our inverse trig function, like so, 2x will be 60 degrees. We don't divide by 2 yet. What we do is we apply the general formula first. So we go 2x equals, and come over to the right-hand side. So I should bring this down again. There we go. 2n pi, we're in radian, sorry, we're in degrees in this question, so that'll be 360n plus or minus 60, and then we divide by 2. That's the trick with the frequency changes. So now we end up with 180n plus or minus 30, and then we can try the n equals 0, and so on. So that's going to be 30, try n equals 1, that should be x equals. X will be 180 plus or minus 30. So that is 150 and 210. They both still fit in. If we try n equals 2, x is going to be 360 plus or minus 30, which gives us 330 and 390. Now 390 is too big. So our answers are going to be 30, 150, 210, and 330. And again, there should be 4 answers because we've doubled the frequency. So there should be twice as many answers inside our normal period. And lastly, just putting it all together. Sorry, I know this is a really long video. Hopefully some of you have lasted this long. If you get something where there's lots of stuff going on in the equation, again, it's all about just isolating that trig function there. So the first thing I would do is divide everything by 2. And then take the inverse sine of it. So inverse sine of a half, which gives us 30 degrees. Okay, and I'll just bring this down here so we can see it. Before we divide by 2, which was the frequency, we apply the general solution. Okay, so that's the key piece of information, is apply the general solution before you divide by that frequency. Now we're in degrees, so n pi will be 180n plus negative 1 to the n times 30. And now when we divide by 2, we'll get 90n plus negative 1 to the n times 15. And then we take away the 60. So it's a little bit messier, this one. So you can see sine, there's obviously a bit more to the equation. And then we just do the same thing, try different values. So if n is 0, we're going to have 0 at the front. Negative 1 to the power of 0 is just 1. So that's going to be 1 times 15. So plus 1 times 15 minus 60. Well, that's negative 45. So that's not in our domain that we've been given in the question. So now we try n equals 1. And x would be 90 plus that. Now that's negative 1 to the 1. So that'll become minus. So it's minus 1 times. So it's minus 15 and then minus 60, which is equal to 15 degrees. And we just go through and try each n value. So now n times 2 is 180. Negative 1 to the power of 2 is 1. So that's going to be plus 15 minus 60 is 135. And we keep going through, and we should know how many answers we're going to get. Remember, the frequency here is 2, so we should get 4 answers. Right now we've got 2. You could keep using the general formula, or you should know that they repeat every 180 degrees because it's the period. So we know we should get 195 and 315, and we'll just verify that that actually is what we got. So here, if n is 3, that's going to be 270 minus 15 minus 60, which is 195. If n is 4, that's 360 plus 15 minus 60, which is 315. And there are our 4 answers right there. So sorry, that was really long, I know, but the key thing is here, use the general solutions if you can. Be aware of how many answers you're going to get. And the big trick is if there is a change in the frequency, don't divide through, like over here, and mine it's working, until you've actually applied the general solution.